Hello. I will continue with the problem set 3, and after this, I will go to the problem set 4. Okay, we have stopped the last time. Then we have done the first exercise, the solution for the first exercise, second, and then now we will come to the third exercise. Okay, what we have here, the pistons are, here you have the pistons of the mechanism shown below, that's here, has the velocity VR. It's unidirectional, go only in vertical direction VR, which is given by 3 meters per second. We have all this, let's say, distance A, 80 centimeter, B, 40 centimeter, and C, 30 centimeter. For the piston here, it's asked to determine graphically, only graphically, not with calculation, the instantaneous center of velocity of the connecting rod here, S, the angular velocity of the connecting rod, S, and the angular velocity of the gear here, R. Okay, now going to the solution. I go here to graphical representation. What we have here, we have the velocity VR. What we said, we need only two, let's say, two velocity, the line direction of the two velocities, and from this velocities we can get the instantaneous center of rotation, or let's say instantaneous center of zero velocity. Then it means here what we have VR, which is given. Then we can draw here a line which is perpendicular to this. Let's say this line here, which is perpendicular to the velocity VR, and we need to determine the second velocity. The second velocity, it means the direction of this velocity. Then we have the point B here, the connection between the rod and the gear. The point here is fixed, that we have this gear, it's rotating with, let's say, omega r. Then what we have, we can get the velocity of this point at this connection, let's say the point B. In this case, we know that VB, it's only the V at the hinge here, which is 0, yeah, plus omega cross the distance here. That we know now that the direction of VB can be given. Why? it's perpendicular to the distance between the point B and the hinge. Then we have the direction of VB, and we don't know, we can calculate it if we have omega R, yeah, but we don't at the moment. We need only to determine the center, the instantaneous center of rotation here. We need only to get the direction. The direction is given here, that it means now what we have, we can get now the perpendicular, the line perpendicular to this velocity VB, then it means this direction. Here we have 90 degree, and here at this point here R, we have here also 90 degree. That it means now we have this point M will be the instantaneous center of rotation. Then it means we have this distance A, and we can measure our reading of this distance D and A. Okay, that is means using the scale of the uh, the picture represented this mechanical system, then we can read now then we have here, we make zoom, the exercise 3. Then we have reading off. We can now read now this angle here, gamma. Yeah, it's only to measure it using um, triangle, let's say, rule. Then in this case, we can measure this gamma. Yeah, we can measure this D, and we can measure the A. Yeah, then if we can do, then we can say from reading off, we can get that omega yeah, omega is 30 degree, and A only A plus B divided by B multiplied by C. Okay, and we get here 90 centimeter. D it's only A divided by sine gamma, and this is give 100 centimeter. And we get F, which is only B divided by sine gamma. This gives 50 centimeter. Then we have from this distance here, E, gamma, E, D, and F. Then we can know exactly where is the instantaneous center of rotation. Then we have the D, we have the E, we have the gamma, and we have this distance F. Now coming to the second question. The second question is asked to determine the velocity, the angular velocity of the rod S. Then it means we have VA, we know it, as we said. VA, by definition in the equation, we know it's at any point, yeah. It's here, VA, it's omega of the system rod, yeah, multiplied by E. Then it's here, if we look well, we have the rod here, let's say rotating with omega S, yeah. When you have the pistons, yeah, going up and down, this system here is rotating, yeah, rotating also the gear. Then we have here omega S, okay, can be determined. This omega S is belong here, the pistons, yeah, is connected to the rod. Then it means they have here only the motion, it's VR. Then we can say that the velocity VR, it's the velocity, let's say, of this point here, which is 0 plus omega S, yeah, here, this distance here, or here, this distance E, yeah. We can say that VR is also Vm, yeah, 0. Why it's the instantaneous center of rotation, then it's Vm, which is 0 plus omega S cross, let's say, this distance here. And as Vm it's 0, then we have here omega S multiplied by E. As we take them as scalar, there is only one direction. Then we can get here from this equation omega S is equal to VR divided by E. And this is give 3.3333, yeah, S minus 1. Okay, this is now the angular velocity of the rod. Now for the third question, to get the angular velocity of the gear, then we have here VB, the same principle, equal to omega r multiplied by f. Then omega r, it's only the angular velocity of the gear. Yeah, if I return back to the picture, we have here VB. Yeah, it's only omega of this, the velocity of this point, which is 0. Yeah, multiplied by plus omega r multiplied by the distance here, f. Yeah, then we can get now omega r it's equal to omega s multiplied by d divided by f. Why? Because here also we can get it, yeah, if we take omega VB, it's also Vm, which is 0, plus omega s multiplied by the distance d. Yeah, this point it belongs to a rod and also to the gear. Then here I can write also it's omega s multiplied by d. Then we get here now VB omega r, it's equal to VR as we defined omega s, we replace it by the definition VA divided by E multiplied by D divided by F. And this gives 6.6 period S minus 1. Then we have the value of the angular velocity of the gear. Now we finished with the set 3. I go now to set 4, and for the set 4, for the first exercise, we have 2 ladders that lean against one another. The left foot here, OB, yeah, remains fixed here in O, and while the right one moves, yeah, to the right with the velocity VE and the acceleration EE. Yeah, then you have the point O, it's fixed for the left foot, and you have the right foot, which is moving, yeah, the point A, it's moving horizontally along X direction. Given is the distance L here, 5 meter, VA 3 meter per second, and the acceleration 1 meter per second square, and you have the angle phi here, which is 130. It's asked to determine the instantaneous center of rotation of the ladder on the right here of this one graphically, the velocity VB of point B, both graphically and by calculation, the angular acceleration of both ladder graphically and by calculation, the instantaneous center of acceleration of the right ladder graphically. Now coming to solution, that's what we know. We know that to determine graphically the instantaneous center of rotation, we need, as the previous example, we need the direction of 2 velocities. We know already one, which is given in the exercise. It's VA, it's horizontal, that it means we have to make only the perpendicular to it. And we have to look for the second one. Then if I come to graphical representations of this, what we know VA, it's horizontally, that it means here what we have the perpendicular that the perpendicular to this VE, we have 90 degree here, give the line, yeah, which is perpendicular to VE. Now for the second one, what we know, for the second velocity means, yeah, as I said that the instantaneous center of rotation needs to know 2 direction of velocity. Now we have one, which is VR, we make the perpendicular to it. The second one, we take the point B, okay, which is the connection between the left foot, the left ladder, and the right one. For the second one, we can say the VB, it's only VO, which is fixed here, it's 0, plus omega, which is v dot 2 here, omega cross the distance here. That it means that if it's omega, it's along z direction, it's given here, phi 2, phi dot 2, it's along that direction. That it means VB is perpendicular to the distance here OB. And it means we know now the direction of VB. Okay, then we have here the direction of VB. Okay, this is the direction of VB. Let's say direction of VB. Okay, now we have the direction of VB. That is means we make only the perpendicular to it and the perpendicular to VB, and we have this. I have to erase this line. We have this direction VB, and this is perpendicular. Then it means now we have the intersection here of the two perpendicular line, and we get now here of this line here and this line, we get the point M. Okay, then we have here now the instantaneous center of rotation. Okay, okay, I return back, I will close it and then I return back to it. Okay, I repeat the procedure, let's say. Okay, we said that we get the direction of VB here. Okay, it's coupled, it's not easy to draw, yeah. Then we have VB here, the direction of VB, and what we make only the perpendicular to this VB. We get here this line, okay, and we said that from VA we have this line perpendicular to VE, and we get the point VM. Okay, this is the center of rotation. Then if we know the angle here 50 degrees, that is means we can get this distance here, EM, and we can determine also the distance BM. Yeah, and it means we have only to measure here graphically to measure this distance BM with respect to the here the scale. And if we do it by calculation, yeah, it's only the angle here 50 degrees. That is means here we get sine, yeah, this distance here, okay. And if we have this distance L, and we have this angle here, which is 40 degree, then we can get also this distance here. Okay, this L, the length of the ladders are known. Now coming to graphically, we said that here we said second, I will make a zoom. Second here we said graphically we have to determine VB, okay, which is known. We said if we get it, we can say it's only VE it's only VE plus VB. Okay, this is, we have seen it that for any point, okay, at any point on the bodies, yeah, they are connected. We can say that VB it's only VE plus the distance VBE. Or we can say also VB it's VO plus the distance VBO. Okay. The first one is belongs to this ladder. The second one is belongs to this ladder. As it's one body here, and the second body. Okay, we cannot make, yeah, but this is VB. We can say VB. Okay, it's VR plus omega cross this distance here. But this is, we can see it later, yeah, by calculation. Then we can say that we know that we are here, we are, it's given, here we said that, sorry, I forgot to select the Word document. Then we said graphically, it's VB, it's VR plus VBR, okay? And here, VB, yeah, we know only the direction, okay? But the magnitude, we can calculate it by VB, it's only VR plus, yeah, the relative, let's say, velocity, which is VBR. okay, and VBR can be calculated by omega cross this distance here. The same we can say for this ladder, the links, the left one. Then we have VB can be calculated also by VO plus VBO. Okay. Now, what we know VR. It's equal to phi dot multiplied by L, the length of the ladder. Why? It's equivalently to say, yeah, sorry, I make a mistake. VI is given, VI is 3 meter per second, but VBA, what we say is the relative velocity can be determined by phi dot multiplied by L. And this is phi dot multiplied by L. It's only omega cross the distance between B and E. Yeah, this is the vector position BE. Okay, the vector position BE. In our case, it's only L. There is only one direction. Yeah, and phi dot is only omega. Then we can say that also that here we have VB. Okay, in our case, what we have here, we can measure it. Yeah, that here if we represent it graphically, what we have here VB, okay. We have VA, we know the line direction of VB, but the problem is only the direction of VB, if it's positive or let's say negative, okay. And this is can be given only by the expression of the rotation. Yeah, it's important the direction of rotation. It's if it's clockwise or counterclockwise. Now we know VA, we know the direction and we know the magnitude. VB, we know the direction, but we don't know the magnitude. VBA, okay, this is in this case what we have. Phi dot or omega, it's not given. Okay, then what will you have VB? A, it's only, yeah, we can make VB. Okay, from the left ladder, it's VO, yeah, plus VBO cross phi dot. In our case here, it's phi dot 2. Okay, phi dot 2, that is means omega 2 of the left one, yeah. But VO is equal to 0, then it means it's only, yeah, the perpendicular, let's say, to here, this VBE, it's only perpendicular to the ladder here. Yeah. Then we can say that now, if we look the direction of VBE, VB, and VR, okay, VB it's only VR plus VBE. Okay, Then we know the direction of VBE, we know the direction of VB, and we know the magnitude of VA, as well as the direction. In mechanics 1, if you have done it, what we need to draw the polygon of forces, yeah, we need either two line direction and one magnitude, or two magnitudes and one line direction. In our case, what we have one magnitude and two line of direction. Okay. Then in this case, what we have VA, which is the magnitude, is given, and we have the two lines of of directions, which is the line direction of VB and the line direction of VBA. Then we can here measure this distance here, and we measure this distance here, and we get the value of VB as well as VBA. Okay. Then if we do so, then we get here reading off. Here VB, what we need, it's 196 meter per second. Okay, this is here what we get from this polygon of forces. Okay, now if we want to get the angular velocity of the left ladder, what we have VB, it's only phi dot 2 multiplied by the distance L, as VO is equal to 0. Okay, then in this case here, we get phi 2 dot, which means omega dot 2, it's only here VB divided by L, and this gives 0. Gives 0 dot 39 1 divided per second. Okay, this is now phi dot 2, and to get phi dot, then we have here, this is only VBA, and in our case for the left foot, VBA will be equal to VB. Okay, then it means what we have here, VB, it's equal to VBA, sorry, VBA, then it means in this case what we have VBA, it's only phi dot 2 multiplied by L. Then we get here phi dot, it's only absolute value of phi dot 2. Why? Because we have phi2 is rotating counterclockwise, is the choice, of course. And the second one, the right one, is rotating, yeah, and in the direction of, let's say, clockwise. Then it means that here we can get, this is means that phi dot will be only minus, here the value 0.93 dot 9339, sorry, 1 over second. Okay, this is what we get phi2. We have also alternative. We can use the instantaneous center of rotation. That it means we have also VA, which is equal to phi dot multiplied by the distance MA here. Let's say this magnitude MA. Then we have here VA is only 3 meters per second multiplied by phi dot, which is here the distance MA, and we have here 7.7 meter. Okay, then we get here now from this value here, sorry, this is here 3 meter per second, and this is phi dot multiplied by here 7.7. This is it's the distance MA. You can read it directly from graphic, and this is we can get here now phi dot. It's 3 meter per second divided by 7.7 meter. And this is will give here 0.39 meter per second. This is the second solution, an alternative to the first one, okay? And we can get it also, maybe we can get it also from the same principle that we have here. VB can be also calculated by phi dot multiplied by MB, and here we can get here 0.39 1 divided per second multiplied by 5 meter, and you will get 1.95 meter per second. Okay, this is the value of VB, and 195 is equivalent to this 196. As I said, graphically, it's not, yeah, the exact value. The exact value can be given only by calculation. Okay. Now, coming to the same problem, we could, yeah, here by calculation. We write here, we get here first right foot or right ladder. What we have here, we take the reference point A, yeah, and we make now the definition here, VB, it's equal to VA, VA plus the relative one, and we write here, instead to write phi 2, yeah, phi dot 2. In this case, we write, as I said, we can write omega, we make a distinction, omega right, okay, the angular velocity omega right. For graphical, yeah, case, omega r, it's only phi dot 2, yeah. Then cross r, a, b. And we have here vector position, yeah. Then in this case that we have here, omega r is taken as positive, yeah. I write here omega r taken, it's only choice, yeah. We take it positive, and after this, if it's negative, you will find a value which is negative, okay. We assume that it's positive, then, and after this, by calculation, we find the right direction of omega. If it's really in the direction of Z or opposite to the direction of Z. Then taken, sorry, once again, positive. Okay. Now, if we write the equation, what we know, what we don't know, yeah? We know only the VA, we know the vector position RAB, okay? But omega R, it's unknown, VB also, it's unknown. Then we can write here equivalently to VB it's equal to VA, yeah, and in the directions VA, its magnitude is given along X direction, Y direction is 0, Z direction is 0, okay, plus omega R we said we take it, assume it is positive in Z direction, yeah, we take it positive. Then it's only in Z direction, then there is no component in X and Y. And here we take the magnitude omega R cross here we take the distance, which is minus the projection of L along X and Y direction. Then we have L cosine P minus phi. Here L sine P minus phi, and you have 0 along Y direction. Then we get here VB as vector is equal to VA minus omega R L sine phi. We have omega R L cosine phi, and you have 0. Okay, in that direction. Now we take here, we took first right eye, okay, right foot. Now we take the left foot, what we have, VB, it belongs to the left foot also, and also to the right foot, yeah. Then we have here, for the left foot, the same principle as before, VB, okay, this is, we can write it by VO of the point O plus omega R, omega left cross R O B. Okay, then in this case, this is also, we can write it VO, which is the fixed point to the left here. The point O here, it's fixed, yeah, as it is said in the announcement of the exercise. Then it means if it's fixed, then the velocity at this point O is equal to 0. And VO is equal to 0, yeah, then there will be only here will be equal to omega L cross ROV. Okay, this is, as I said, it's okay. Omega L, of course, it's taken positive. Yeah, I mentioned it here. Omega L taken positive. Okay. And the direction of it will be, yeah, determined by the calculation, by the value. Then in this case, what we get here VB. If I write it in component, it will be equal to 0, 0 omega L cross now ROB here, it's only L cosine pi minus phi and you have L for y direction, L sine pi minus phi and 0. Okay, then we get here VB, it's equal to minus omega L sine phi minus omega L cosine phi in y direction, and the z direction is 0. Okay, then what we have here, we have this equation here, I call it 1, and we have the second equation 2, and we have to make only the equality between the two terms. Okay, then what we get here, 1 then 1 equal 2, then it means we get here VE minus omega R L sine phi. This is for the first term here, and second term in y direction, we have omega R L cosine phi. This is will be equal here we have minus omega L sine phi, and here equal to minus omega L multiplied by L cosine phi. Okay, then we have here the third one equation and fourth one. Okay, now from the fourth one, okay, we get here dot omega r L cosine phi, it's equal to minus omega L cosine phi. Okay, then it means we get here omega r, it's only minus omega L. Then it means they have the same, yeah, the same magnitude, but opposite directions. Yeah. Now, if we take the third equation, then we have here VA plus omega L, L sine phi, equal to minus omega L if I replace by omega R by omega L minus omega L, then we have here L sine phi. Then what we get here, we get that VA is equal to minus 2 times omega L sine phi. Then we get here omega L equal to VA divided by 2L sine phi. And this is, you get here with minus sign, yeah. This here we get minus 0.391 divided by second. This is omega L, yeah. And as I said, omega L, omega R, it's only minus omega L, yeah, is the same value, but opposite direction. Okay, to get VB now, VB, if I use the previous, either you use the first or second, this equation, or you use this equation, yeah? Then we have here, if we take the second one, then we have here VB, it's equal to VA divided by 2L, which correspond to omega L, 2L sine phi, multiplied by L sine phi, and you have BA in y direction to L sine phi, L cosine phi, and in z direction it's 0. Okay, then if you replace each value, then you get here equal VA divided by 2, VA divided by 2 times tangent phi, and 0. And you will get here 1.5 minus 1.26 and 0 meter per second. Now VB as magnitude, it's only square root of 1.5 square plus minus 1.26 square here meter per second. Then we get here the value of VB. It's equal to 1.96 meter per second. This is the value of VB. Okay. This is what we get here. Now coming to the third and fourth question to determine the acceleration of the point B, yeah, graphically and by calculation. Then we have here third acceleration. We have A graphically, that we know that here now if I come to the graphic solution, That's what we have. We have always, yeah, EBN. We know that the acceleration is only the sum of three components. Let's say I write here EB, yeah, for the left foot will be EO here, which is in our case, it's fixed point, yeah, and it's 0 plus EBA, okay? But EBA, we said that there is also two components. There is the normal one and there is the tangential one. This is the tangential one and there is the normal one. That it means if I can write here for the left foot, left foot, we have EBA, it's only here EO plus EBN plus EBT. Okay, there is the tangential. EBO is here 0. And we have for the right foot, we have here EB, it's equal to EE plus EB A normal plus EB A tangential. Then this is the relative one. Here in our case that we have, this is 0 that we can decompose. EB, it always has normal component and tangential component. Okay, and this is here, it's the relative one. Yeah, as we take, this is the frame case, and this is here, we take it as the relative one. Then we can decompose here now. We know that EBN, it's only omega cross the vector position, and EBT, the tangential one, it's here omega dot, yeah, cross the vector position. For the left one, omega, it's only phi dot 2, and omega dot, it's only phi dot 2. And here, the same principle as this one, okay? Here we take phi dot, which is correspond to omega, okay? And phi dot dot for omega dot. Now that is means here for the left foot, we have ABN, the normal one, that is one directional on the plane that we have here, phi dot 2 square multiplied by L, okay? And we know already the value of phi dot, yeah? Then it means here we can get 0.76 meter per second square. Now, if we come to EBT, this is magnitude, sorry, yeah, this is will be equal to phi dot dot to L. Now, here what we have EBN, we know the magnitude, and also we know the direction. EBT, we don't know the magnitude, but we know the direction. That it means here we have EBN, we know the magnitude, also the direction, okay? EBT, we know the direction, but we don't know the magnitude. That is means here, it's making a 90-degree with this because it's omega dot or phi dot, yeah, phi dot dot 2, which is cross this vector position OB, okay? Phi dot dot, or let's say, better to say omega 2 dot, it's along Z direction, we have X direction, Y direction, and this means if you make this Z and this direction here along this axis, then it means it's perpendicular to the plane. If it's perpendicular to the plane, then it will give perpendicular to vector position here. Then we'll give EBT and here EBN. Okay, then we can draw the polygon of forces, yeah, the same principle, like we have forces as they are vectors, yeah. Then we have here EE as magnitude is given, okay. And additionally, what we have EB, and as magnitude also we have calculated it, yeah. It's 0.76. Then we have EBN as magnitude, yeah. And we will see now what is coming to other. Now, if we take the right foot, we have angular velocity or angular acceleration. We take them as phi dot and phi dot dot. Then we have here AA, it's given in the exercise, it's 1 meter per second square. And we have AB, A, the relative one, normal, okay, as magnitude. This is phi dot square multiplied by L. And we know the value. It's 0.76 meter per second square. Phi dot is only phi dot 2, yeah, with opposite sign. And we have ABN, ABRT. Now, tangential one, this is equal to phi dot dot L. Okay, phi dot dot is unknown, then it means we know now the direction. As we said, it's only omega dot cross vector position. It will be perpendicular to the plane of vector position or to the line of vector position. Here we know the direction and we know also the magnitude. Okay, then if we do so, then we have here, we come to the polygon of forces. We know EB and magnitude direction, EA magnitude direction, EBR and magnitude and direction. Yeah, then it means now what we have EBT, we know the line direction, okay, and then we can draw EB, it's the sum of the EBN and EBT, yeah, the two the two components of EB. Then we can get directly now, yeah, the value of EB as we have here. EB also it's the sum of AA plus EBAN and EBET, but EBET we know only the line direction. Then it means the intersection here will give the magnitude of EB. Then we can measure or reading of the value of EBT from this point, of EBT, yes, from this point to this point, and we read the value of EBRET here from this point to this point. Okay, then we get all value, yeah, only by reading of the value. Then we have here reading of we have here E, B, E, T. This is will be equal to 1.3 meter per second. And we can get here now from this, as it's EBET, it's only phi dot dot multiplied by L, yeah. Then we can get here 1.3 meter per second square. Sorry, here second square. This is will be equal to phi dot dot multiplied by L. Then we can get here the angular acceleration phi dot dot will be equal to 0.261 over second square. Then we have here the angular velocity. Now, if we come to the by calculation, then we take, as for the velocity, we take left foot. We have EB, we have EB as vector. It's only E, B, N, the normal component, plus E, B, T. Then it means it's only here. I make like this. For the EBN, it's only omega L cross omega L cross R OB plus the tangential one omega dot L cross ROB. Okay, then if we take as a component of it, that's what we have here for omega L. We have 0, 0, omega L. We take them as positive direction for omega L cross here 0, 0, omega L cross ROB. ROB is L cosine P minus phi. Here L sine P minus phi and set direction 0. Okay, this is for the first term here. Okay, this is will be this one here. Okay, plus the second term here. Okay, then we have here plus then we said plus the second one is only 0, 0, omega dot L cross the same here for ROB. If we decompose it, small minus L cosine phi, and here we have L sine phi and 0. Okay, then this one is only the green one. Yeah. Then if we decompose further, we get here EB will be omega L square L cosine phi minus omega L dot L sine phi minus omega L square L sine phi minus omega dot L cosine phi and 0. This is one side. Yeah, I wrote it by I. Yeah, or I note it by I. Yeah. Now, if we take the right foot, then we have the same for EB. It's only EE plus EBE normal plus EBE tangential. That if we decompose further, then we get here EE is given only in X direction. Yeah, it's given in the exercise EE 0, 0 plus. Now we have for EBN, it's only omega R vector cross omega R cross R EB. Yeah. Then here I can write it to better understand. This is EE. Okay. Plus omega R cross omega R cross R EB plus here omega dot R cross R EB. This is R by definition, yeah, the equation to determine the normal and the tangential one. Then it means here plus here we said for omega EB n, then we have 0, 0 omega R cross 0, 0 omega R cross here L cosine phi and here L sine phi and 0 and plus 0, 0 omega R cross The same here, L cosine phi, L sine phi, 0. Don't write it, it's 0 here, yeah? Then if we develop further, we get here AB, then you get AA minus omega R square L cosine phi minus omega dot R L sine phi, and here minus omega R square L sine phi plus omega dot R L cosine phi and 0. Then this is, I said, I note it by the 2. Then which means if we have here with equality, 1 equal to 2, then we have here, we get that I write the equation here, minus omega L square L sine phi minus omega dot L L cosine phi equal to A minus omega omega R square L cosine phi minus omega dot R L sine phi, and the second one that we have here omega L square I return back here to the equation omega R square write it differently. Then we have omega r with minus square L sine phi plus omega dot L cosinus alpha phi omega dot r L cosine phi, and this is equal, if I take this one, minus omega L square L sinus phi minus omega dot L cosine phi. Then this one here, minus omega L square L sine phi minus omega dot L cosine phi. Okay, I check only minus omega L sine phi minus omega dot L cosine phi. Okay, this is the two equation. If I develop further, then we get here omega dot L will be equal to minus omega dot R. As for omega, here we have omega dot the angular acceleration, and from the first equation that we get here, omega dot R will be equal to AA minus 2 times omega R square L cosine phi divided by 2L sine phi. And this will be equal to 0 to 6 1 divided by secant square. This is now the angular acceleration. Now coming to the fourth questions, the instantaneous center of acceleration. Then we have here EA. We get here the magnitude and the direction of AB. Yeah, the acceleration of the point B. We said to get the instantaneous center of acceleration, it's only counterclockwise. We rotate with the angle beta. Okay, rotate with the angle beta from the direction of the acceleration in one point. From the second point here, where we have here AA, the same we rotate with the same angle beta. Then we draw the line, and the intersection of the two lines here, the intersection of this line with this line will give the center, instantaneous center of acceleration. We note it by F. Okay, to determine beta, how to know beta now, with which angle we should rotate. Yeah, beta, I write here fourth question. Beta, it's always defined by arc tangent of phi dot dot divided by phi dot square, or we write it also by arc tangent of omega dot divided by omega square. This is by definition, yeah, and we get in here 59.7 degree. Okay, this is now the angle beta. We know phi dot dot, we found it here, okay, or omega dot, and omega, we know it from the first question about the velocity. Then we have the angle here, then we rotate with this 59.7 degree, yeah, counterclockwise, and then we get, yeah, the two line, the intersection of the two line, we give the point F, which is the instantaneous center of acceleration. Okay, I will finish here. Yeah, I will continue next Sunday with the exercise 2 and the exercise 3. Okay, see you. Bye.